All right, so in number 3, what we have here is a quadratic over a quadratic, which would be greater than 0. So before we even, well, let's decide, step 1, what kind of numbers are we looking for that are greater than 0? All right, we don't want 0, correct? So I'm going to get my highlighter out and I'm going to highlight the fact that I'm looking for positive intervals or positive values. Whatever will make this side of my inequality positive, that's what I want. So I'm going to bring in a picture of this graph. So this is the graph that represents this inequality. And you'll notice, if you'll look at it, that it has 2 restrictions and it has a hole in the graph. Do you see that? And then it has a space where there's nothing graphed. And then it has a 0 here. Okay? Yes. Well, it doesn't go through the restriction. There's a hole in the graph. So, and that's created because in my numerator and my denominator, I'm going to end up with a binomial that repeats. So when I get a binomial that repeats, you'll see it when we factor it. When a binomial repeats, it creates a hole in your graph. Okay? So let's look at this interval here from -infinity to -3. What kind of numbers are my output? What kind of numbers are these that are above the x? No, above the x, people. These numbers above the x are positive. So this is a positive interval. Between -3 and -1, what kind of numbers am I getting out? Positive. Going from this interval, from -1 to 1, what kind of numbers are coming out? Those are negative, so that section's negative. And then when we go to this side of our last 0, which is 1, we're getting positives again. So if I were to guess at what my solution was going to be, I would say from -infinity to -3, but not including -3 because it's a restriction, will be part of my solution because that's positive, yes? Then in union with the next interval, which is also positive, from -3 to -1. Non-inclusive again because those are our restricted zeros. In union with, skipping over this section, right, to the 0, which is a 1, to infinity. So based on my graph of this inequality, this should be my solution. Let's see if we can make that happen without this graph. Ready? Yes? Okay, so let me move that guy out of the way and do a little erasing of my signs. Okay, so that's my prediction for our solution based off of the graph. Let's go to step 2. So we've decided we have positive intervals. That's what we want. Step 2 is to factor. So I am not going to factor it for you. You are going to factor it. I'm going to give you 45 seconds to factor the numerator and the denominator, and then I'm going to call on you to tell me the factors. All right, so let's go with David. What are the factors of our numerator? X minus 1, thank you. That's all I needed from you. Awesome job. Let's go to the denominator and factor Sunny. Go. Beautiful. Okay, taking it back to our conversation, Calais, a little bit ago, do you see what numbers that I could, if I wanted to, I could cancel them out? And remember what number that was on our graph? Oops. It was the -3, right? And see how it created a hole in my graph? So that's why that happened. Great question, by the way. I'm so glad you asked it. Okay, so let's move to 3. Step 3 is to find our zeros, correct? All right, so let's look at our numerator. And I'm getting a little bit more efficient with my zero finding. So let's take a look at our numerator and what number makes our first binomial 0? -1. Isn't it just 1? And what's my other 0? -3. And of course, if you still want to write them out as x minus 1 equals 0 and x plus 3 equals 0, so you can find your zeros. I'm not asking you to to stop doing that if that is getting you where you need to go. I'm just becoming a little more efficient as I go. Okay, let's take a look at our denominators. What is our 0 for our first binomial? -1, and our 0 for our second one is also -3. But we have to remember now that our denominators are not allowed to equal 0. So we're going to call our denominator zeros our restrictions. We don't want those. Okay? Because calculator, if we put a 0 in the denominator, the calculator is going to tell us error. Can't do that. Okay, so let's make our number line, which is also part of number 3. And we're going to stack. Well, let's do our zeros. So we have, what's our smallest 0 here? -3. And then 1. And we're going to stack our 4 binomials over here off to the side so we can create our sign chart. So x minus 1, x plus 3, x plus 1, and x plus 3. And we'll do our zeros. We'll extend them up so that we can create our sign chart. So we're extending our zeros up to the line. So what's our first 0? For x minus 1, our 0 was 1. So to the left of that, we would create, if we were to plug numbers to the left of this 0, like if I plugged a 0 in right here, because 0 lives right here. Do you guys agree 0 lives right here? 0 minus 1 is -1, right? If I plug in a -2, -2 minus 1 is -3. If I plug in a -4, -4 minus 1 is -5. We can trust that to the left of a 0 we get negatives, and to right of a 0 we get positives. And until something changes our mind about that, that's the way it's going to be. Let's go to our 0 for x minus x plus 3. That would be -3. And you know, I think I'll just do both of them at the same time. Okay, so we'll go negative to the left of those and positive to the right. Because why not? And then we'll go to our last one, which is x plus 1. Its 0 is, what makes this equal 0? -1. And to the left of that, we would create some negatives, and to the right of that, we would create some positives. So those are our zeros. Okay. All right. So now let's go and restrict. We don't want -3 as part of our solution, right? So I'm going to put some parentheses around that guy. And we don't want -1 as part of our solution, because that's also a restriction. And I'm wondering, do we want the 1? If you go back to step 1, do we want the 0 from our numerator as part of our solution? Are we looking for zeros? No. And if I plug a 1 in, people, just so you can believe me, if I plug a 1 in, watch, 1 squared plus 2 times 1 minus 3 over 1 squared plus 4 times 1 plus 3. Well, that's 1 plus 2, which is 3. 3 minus 3 is 0. And 0 divided by anything is 0. And I don't want 0 is greater than 0, so I don't want that. I don't want that because I'm not looking, it doesn't have an equal to 0. It wouldn't even matter what my denominator is. In this case, I think it's 8. It doesn't matter because, you know, 0 divided by anything is 0. So that's the reason we're not including that 0, if you were wondering. All right. So now we want the positive sections. So let's figure out what kind of section this is. So just so I show this to you a little bit differently, these two represent my numerator, right? The first two? Yes? So if I have in the numerator a negative times a negative, and in my denominator I have a negative times a negative, that's positive over positive, right? Which is positive. So that would create a positive situation because all of these would create negative numbers. Now if I go to this one, if I have a negative in the numerator and a positive in the numerator, and a negative in the denominator and a positive in the denominator, this creates a negative over a negative, which is also positive. If I go to this one, I have a negative in the numerator and a positive in the numerator, and then I have a positive in the denominator and a positive in the denominator. What does this create? A negative. And then, of course, these are all positive, so positive. Shortcut for figuring out which ones are positive, which ones are negative is you count the negatives. If it's even, 1, 2, 3, 4, positive. Even, 1, 2, yeah? Positive. 1, that's odd, negative, yeah? So that's a shortcut. So we want to go back to the question that says we want the positive intervals or the positive sections of this number line. So we want this section, we want that section, and we want that section because we want the positives. And is that not what we wrote to begin with? From negative infinity to negative 3, but not negative 3 because it's a restriction. From negative 3 to negative 1, but not negative 1 because it's a restriction. And then from 1 to infinity, but not 1 because the 1 created a 0. We don't want that. Okay? Questions about that? I'll tell you that I have a major quiz on Thursday on this stuff. Question? Sarah? Can I what? Scroll up? You need me to pull that up to the top? This part? How's that? You bet. Of course. What else can I do to help before we go to the next page? Yes? It is a restriction. That's why we don't have a bracket on the negative 3, because if we put a bracket, then we would include it as an answer. It is. If it's a restriction from the denominator, it's a restriction overall. So it is a restriction. Anything else? Okay, moving on to the last problem. Let me erase my mess. Okay, so what do you notice here that's a little different than the ones that we've done before? There's a cube in your numerator, yeah? So what we call that is not a quadratic. We call that a cubic. Wow, that's just a real big stretch, right? A great stretch. It's got a cubic. If it had a 4 in it, it'd be a quartic. So why is a 2 a quadratic instead of a squaredic or something? I don't know. But in my numerator, I have a cubic. In my denominator, what do I have? What do you call it when it's to the first power? Starts with an L. Linear. So I have a cubic divided by a linear. Well, what kind of answer do I get from that? A what? Quadratic. Yes? X cubed divided by x is x squared. And what a quadratic's graph? Check this, guys. So, wait a second. That doesn't feel right. Look at this parabola. So let's just see if we can determine what our answer is. Now we know that we want what kind of numbers that are less than 0. So we know we're looking for the negative intervals, right? We know that. So I'm going to highlight that I want that. Now let's just see if we can determine what our solution should be. Do you need me to make that bigger? Are you good? Jonah? Do you do that to help you see? I do too. It helps you focus. Okay, so let's look. Here's a 0. This is a 0, and there's a 0, and there's a 0. That's a restricted 0. To the left of this 0, what kind of numbers are we getting? Between these two zeros, what kind of numbers? Between these two numbers, we're getting, and after that number, we get positive. So if we were guessing our solution, we would say this is -1. Do you agree? That's -2, because that's 0 right there. So from, do I want the 0? Do I want the -2? So from -2 to -1, but I don't want -1 because it's a restriction. And then from -1 to 0. And do I want the zeros? No. So that's my prediction of what our answers. That's Rudolph. Look, see his little red nose and his antlers? He's so cute. Okay. I'm going to move him out of the way now. And let's see if we can't make that happen. I don't want to clear that. I'm looking for my eraser. There we go. Okay. So let's go to step 2 and factor your numerator. And it has to factor 2 times. So I'm going to give you, what, 40 seconds to factor, and then I'm calling on somebody. All right, so, Tyler, go. You guys agree? Me too. Beautiful. And our denominator does not need to be factored. So if you were wondering how Tyler did that, he noticed immediately that they had a common factor of x, so we factored it out, leaving him with x squared plus 3x plus 2. And then he, of course, broke up his binomials, pairs, 2 numbers that multiply to 2 and add to 3. So it was beautiful. Thank you. Okay, so now let's find our zeros. Are you ready? So in our numerator, our x is equal to, what's our first 0? 0. What's our next 0? And our last 0. And in our denominator, our 0 is negative 1. And in our denominator, we can't have 0. So this guy right here is our restriction, which means it's also restricted from being in our numerator because it creates a 0. In our denominator, we can't have that. Okay, so now we're going to create our number line. Ready? Oh, let's stack. Let's stack first. So we have x and x plus 2 and x plus 1 and another x plus 1. Okay. So which is our smallest 0 here? Negative 2, then negative 1, and then 0. Okay. So we'll split up our number line into our intervals, and we will start finding our zeros. So our first 0 here is 0. For x, if x is 0, then left of that, of course, would be negative, and to the right of that, of course, would be positive. For x plus 2, our 0 is negative 2. So to the left of that would be negative, and to the right of that would be positive. Then for our last 2, they have the same 0. So to the left would be negative, and to the right would be positive. And let's go and deny our negative 1 from our solution because it's a restriction. And then let's change colors and decide if we want to include our other zeros. Are we looking for zeros in this problem? So we don't want to deny them, but we're not going to include them. And now let's count negatives. So how many negatives here? So that is going to be positive. Here we have 3, which is, here we have, which is negative, and then, of course, positive. Now that we know, we're going back to number 1 to say we wanted the negative sections. So we wanted that section and that section. And if we were to go look at our prediction from our graph, we did it right again. And so there you have that. Now you might think we're done with notes, but we are not. I am going to add a twist because you will have a question on number 6 on your assignment. So we're going to address that right now. Let me erase and we will start over. So this one we won't take a lot of steps. You won't have to factor or anything. So we're going to take number 5 and just stick it under number 4. You should have some room. Shh. So we're going to do number 5. And number 5 says this: negative 10 minus x over x is greater than or equal to 0. So we have something different that we have not seen before. In our numerator, we have a negative x. We've never had that before. Always in our numerator, we've had a positive x. So this changes things. So step one, we're going to determine what kind of numbers do we want if it's greater than or equal to 0. Positive and 0, that's what we want. So I'm going to highlight that that's what I want. And then step two is to factor my numerator. But I don't really think it needs to be factored. I think it just needs to be solved. So step 2 is already factored. We don't have to do that. Step 3. Now, here's the difference between students who get A's in my class and students who get B's. A student who gets an A will be very careful about finding the 0 for the numerator. A student that gets B's will try to do it in their head and half the time make errors. I can always tell the difference between an A and a B student. So what we're going to do with our numerator is we're actually going to set it equal to 0 so that we make sure we find the correct 0. We're going to be A students. So we're going to add 10, right? So we get negative x equals positive 10. Divide by negative 1, and that should put us on alert. That's negative 10. Yes? And if I were to divide this by negative 1, what would it do? Reverse my, yeah, it would. You're going to see a reversal happen here in just a second. So that's my numerator 0. So I'm just going to write zeros right here. That's my numerator 0. What's my 0 for my denominator? Go back up. What is it? It's 0. But it can't be 0, remember? So that's my restriction. So I'm going to put a little bubble around that so I can highlight that those are my zeros. I didn't do a very good job of separating that. Okay. You're so nice, Seth. Okay. So now I'm going to make my number line. And I'm going to put my negative 10 and my 0 on my number line. And I'm going to stack my two polynomials, negative 10 minus x and x. And if you don't like that x in the back, you can put negative x minus 10, and that doesn't matter. But here's where we can't be lazy. We have to actually, because this throws things off. We've never had a negative x here before, right? They've always been positive x's, which means we can just go to the left negative to the right positive. Okay, so this is the 10 for this. You agree? I mean the 0. This is the 0. But on the left is not going to be negative. Here's how we're going to check. Would you say that negative 11 is on this side of negative 10? So if I plug that in, negative 10 minus negative 11, that's positive 1. So when you have a negative on your x, it reverses your positives and negatives. Let's pick a number in here. We want to pick negative 5. Negative 10 minus negative 5. That's negative 5. That created a negative. Plug a number in here, like 1, right? Negative 10 minus 1, that's negative 11. So that negative on the x reversed your positive and negative signs. Trust that, because that always happens. Okay? Now let's go back to this x, which is 0, is here. And if I plug in a negative 5, well, that's negative. If I plug in a negative 11, that's negative. And if I plug in a 1, well, that's positive. So that's the thing that we probably want to be on alert about. It reversed everything. That negative on the x reversed your positives and negatives. Do you have questions about that? Because I want to know. Yes. You could. You could have just added x and had x equals negative 10 immediately. That would have been smarter and faster. I'm glad you saw that. Awesome. Okay, so take a look at our first interval. We have a positive over a negative, which is negative. Negative over a negative, which is? And a positive over a negative, which is? And that's also the opposite of what we usually see, correct? So we have to just really be on alert. about that negative on the x because it changes your life. You'll get it exactly wrong if you're not paying attention. So what were we looking for? Positives and zeros. Oh, I forgot to deny our 0. Remember, let's deny it. Deny 0 because that's a restriction. But we wanted to include the other 0 because we want the 0 from the numerator. So we'll take the 10. So our solution would be in the positive section and including negative 10, but not including 0. Okay? So I would say that question number 6 on today's assignment, you'll need to refer to this question. And then tomorrow you'll refer to it often, often, often.